What's up, everybody? Welcome back. Today we are working on a toy example for working with WebAssembly as a extension system for like a desktop application. And today I wanted to look at like string manipulation and struct manipulation. So last stream we were looking at this, and we wrote this like WebAssembly module that computed the power of some base to some exponent by running a loop and multiplying it by the base, multiplying the output by the base over and over again. Simple, right? Nothing too crazy in there. And we like loaded this WebAssembly module in both a Zig application as well as the browser, as well as like figured out how to like inject some callbacks that go the other way. So like from this module, we had the ability to like call some C function or call some JavaScript function depending on like which environment we had loaded it into. We kind of got to the end of that, and we kind of understand like how to get numbers in and out of like a WebAssembly module, but the idea of working with text is like a little more complex. So I think that there's some sort of like memory allocation stuff that we have to do to make that work. I don't really know how yet. And then there's some sort of like, I want to look at like struct manipulation as well. So say we wanted to, say we have like some structure, right? It's just like struct like position, and it has like an X float, Y float, and Z float, right? So we have like three things in a structure. Can we work with that in C and then pass it into WebAssembly? Is that something that we can do? Does it work? I don't know. And so I want to look at that as well. So I think probably what we're going to start with is maybe building up some sort of system to run a WebAssembly module as like some sort of text filter. And then from there, maybe we will try to like do one text filter in like raw WebAssembly, one in C, one in Zig, and compare the differences, and then drop from there into like the struct stuff. It's really warm in this room all of a sudden, so I'm gonna be right back. Just give me 1 second. I gotta go get a t-shirt. I should have done the like Amaranth BRB changing, putting on nice bikini, but I didn't think of it, so too late now. Too late now. And this is a programming stream, so let's jump into it. Let's jump in. Okay. So let's look at the WebAssembly reference that we were using yesterday from Mozilla, and let's see if they have any tips for us on how to like interact with strings. Okay. So I think we were looking at this understanding WebAssembly text format, and let's just see if they have any like string IO examples in here. They have like this concept of memory, which I assume is going to be related. Console log string. Okay, this is promising. So this example has some console log string function. Do they pass that into this thing? So they pass it in as console log. And in their console log, they say, hey, we have this thing that we want to punch in, and its parameters are actually integers, which is interesting. So he takes in 3 integers. One is the which chunk of memory they're using. Okay. One is its offset into that chunk of memory. Okay. And then the other is length. Okay. So it looks like hand wavy. It looks like we have to like instantiate WebAssembly memory segment. We have to specify where in the segment it is, and we have to specify its length. So it's like very similar to like C string APIs, except that we have to, instead of using pointers, we are using what looks to be I32s that are representing offsets into some memory bank. I assume that you have to pass in this memory bank from externally. No, you don't. It looks like you can either ask JavaScript, or in our case, it would be C, to construct this memory bank, or we can construct it internally. So what does it look like if they construct it internally? They create some memory segment, and they say, hey, this is our memory segment. Okay. Then they attach data to this thing. Oh, this is probably like inline strings. So in like assembly, you can like, you just like write data to some location in the binary and then reference it later. This is probably the same thing where they're saying like, hey, I am in memory 0 at this offset and just write this data there. Then they are pulling that data back out and logging it. Okay. So we can do like a simple little hello world probably. We can maybe make a function that's like, hello. Actually, maybe we don't even need the function, do we? Let me think about this. Yeah, let's do it. Well, yeah, let's do it through a function. So we'll say hello world is going to be our function, and he's going to take in no parameters, and he's going to return nothing. Yes. And we are just going to try to call a function with some data associated with it. So we need to like we need to create a memory bank, it looks like, hand wavy. So we can like create a memory bank and we say, hey, I want this memory to exist. And what is this like parameter here? What is the parameter? Where do I see here? Memory? Memory. WASM memory. Or WASM instructions, I think, is where we were looking yesterday. Or 2 days ago, I should say. They have memory instructions, and one of them should just be like create. No, these are like instructions to act on memory. But how do I like make memory? Control flow? No. Variable? Get global, set local, declare global. No, this isn't really what I want either. It feels like it should be under memory, but none of these things seem like what I'm looking for. Okay. Where is this defined? Memory mem1. I swear I've seen it somewhere. I think I saw somewhere when I was browsing this the other day that it's related to like pages. Where would I have seen that? Was it just here? Yeah, for this example, this is where I saw it. For this example, we'll create the memory in JavaScript and import it into WebAssembly. First, we create a memory object with one page and add it to our import object. Yeah. So here they're saying, hey, we want some memory with one page. And here in this other example, we were creating memory with one page, I guess. And I think I saw somewhere that the pages are 64K each. Sure. So we'll say, hey, we want to create a memory mem with one page by default. Maybe we can grow it later. Not really sure. We need to export this thing as something that can be viewed externally. So here we say mem is going to be memory 1. Is that what they do? No, they name the memory. So here we're saying we're exporting memory mem as the name mem to some JavaScript or C. We should be able to then shove some data in here. So here we're saying, hey, I'm going to put some data in some memory. Is there a data instruction that I can look at? WASM data instruction. Instruction, data. Variable. Memory. Like, I swear there should be one in here, but maybe not. But WASM data. I just want to know what it is, you know? Numeric instructions, blah, 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 memory instructions. So this is none of the ones we're looking for. I'm just looking for anything that says data anywhere. No. Tables, no. Global, local, no. Mul, no. These look like math operations, which isn't what I want. Like, What the hell? Like, why? I'm not even seeing like import in here. Like, where does it define like this and this and this? This is what we need to know. Structure. Let's see. Types. Okay. Oh wait. Okay. Memory types. Table types. Oh, that's not helpful. Linear memories. Mems by their memory type, blah, blah, blah. Data segments? Okay. So data is whatever the fuck this says. Data is init vec byte mode data mode. That doesn't look like this at all. That doesn't look like this at all. Where does it come from? How do I know? How am I supposed to know? Okay, I guess we will just work through the examples, like, just kind of guess based off of this example page for now, but it's kind of pissing me off that I don't have, like, an official reference to look at. So, but we can just look for data, and so here, someone should tell us what it does. Oh, someone's got me a link. Okay. So what is this saying? This is saying the curly braces, do they mean one of these or all of these? Data, mem, IDX. The initial contents of memory are zero-valued bytes. The data component of a module defines a vector or data segments that initialize a range of memory at a given offset with a static vector of bytes. Data, mem index. It just doesn't feel like this is like the WebAssembly text format spec. Maybe that's what I'm looking for. WASM watt specific like spec. Right, because this feels like it's not telling me like the syntax, which is what I'm most interested in, is like, what do these components of the syntax mean? Yeah, it does look like text format. Oh, here we go. Wait. This is promising. Here we go. Wait. This looks promising. Very promising. Data segments. Here we go. Okay, yes. Okay, perfect. This is exactly what I wanted. So you have an open brace, then the word data. ID, where ID is like this thing. And does the question mark here mean that it's like optional, maybe? So here we have data bracket memory. What does that mean? Which one of these things says which memory it is? Here, memuse. So we're in this version of the thing. So we have data followed by ID followed by memuse, which is optional. I don't know what this arrow to X thing means. Then this is where the offset, which is an expression. But we don't have the word offset here. But they do. But maybe we copied it wrong? Let's see. No, they just say that the offset is like, I guess, like a definition of some I32, which is 0, which makes sense. Okay. This is starting to get, we're getting somewhere. And then this is like what's in the data. And then this constructs this thing. I see. So they're probably saying that this is like a named thing X, and that X shows up over here. Okay. So what is this ID? Oh, I see. So we can name our data thing. I see. So we can name this data like hello string. Do we have to specify the memory? No, we could just do this. Right? So we say data ID data string, which is just this. This looks like the simplest version of the thing. This comes up here. Now, for our hello world thing, we're going to say, hey, I want to call some function with this data string. That makes sense to me. So we need our imports again so that we can call some log function. We lost that at some point. So here we can say we import from env log some function that takes in 2 i32 parameters, which are going to be the location of the text as well as its length. That seems reasonable to me. And we're going to name this thing. How do we import this thing and name it again? We name it here. Yes. And then we can just push. So to call this hello world function, we're going to say, hey, let's take the location of hello string, which I don't know how to do yet. That must be one of the... Well, let's look at this example again. Surely they do it in here. They get mem index, mem offset, and then these are just kind of hard-coded, which isn't really great. I want to know like how to go from the name that we gave it to a memory location, which must be done somewhere in here. It must be. It must be. It must be. It must be. Data. Do they name it ever in these examples? No. Okay. That's okay. Well, we can figure it out. We can figure it out. In here, we can create a data segment. Maybe it's like a memory instruction. I want like, for example, we can local get these things. Oh, that's folded instruction. That's not what I want. Not what I want. Mem arg is an offset and a line. Oh, and then I can say i32 load from memory. Okay. Can I ask for like the location of some data? Table instructions, reference instructions, control instructions, web assembly text get length of data by name or something. Let's just like see if Google will tell us. Here we go. This guy's got some questions. But it doesn't quite look like what I want. But let's see. So this is JavaScript. This is WebAssembly. Size. Wasm text instruction. No. I was close. Felt okay. Surely there's like a way to extract the data location. WebAssembly text get location of data. How to load. Okay, this guy's. You can find the definition for data segment syntax in the web text format specification. It's quite straightforward. Okay. Finally, data is the data itself. Offset is the const expression. So they're saying that we kind of have to say exactly where it is. Is that what we saw when we looked at this? Did I just misread? Did I just misread? Yeah, you're saying that I can get a value at an offset by using the number itself. But I was kind of hoping that since it was saying that I could name the data segments with this ID, that I could extract it by that ID, if that makes sense. Right, like this version. This version of the thing is different. This one tells me, hey, I want to use the data at like offset 0 in the data blob. But here, I'm just saying, like, I have this thing, it has a name. Like, how do I use it in that case? Also, memory use could be omitted. Okay, well, let's compile this and see if this even compiles, because maybe we just don't understand. Maybe we've made a mistake reading that thing. So what to wasm. Imports must occur first, so this has to go up the top. Unexpected character at 7, so this has to be like this. Okay, so that compiles. Can we do like local get hello string? And then, like, what does this do, I wonder? Const, then we can do like, let's just pretend that this returns a i32 and just see if this compiles still. Because if that compiles, we give something. Okay, undefined thing. What about like data.get? Is that like a thing that exists? No. Let's look at like the memory instructions. Maybe i32 load data hello string. That sounds like it could work. What is i32.load? Let's see if we can find that. That sounds promising. That sounds like something I would believe exists. i32 load. Used to load a number from memory onto the stack. Load the first item in memory and return the result. Scroll a bit down. Ah, okay, wait. Okay. So I can load from name memory 1, offset in memory to load from. Is there like data in here anywhere? No. i32 load from data name or something. Like it just feels like syntax for referencing data offsets and table elements in code. Okay, if the data changes, the offset needs to be updated manually. Typed data. Like, is it just inferred that the offset is 0? Like, it does seem like this guy's kind of saying that you can't do it. Right? But it's weird to me that this compiles if it's unusable. Right, okay, let's start for now with just saying, we'll do the other version. Just for a second, just to, like, get something visible, and then maybe we'll come back to it in a second. So we will do this. Offset abbreviation, blah, blah, blah. Okay, yeah, so we'll just say offset 0. i32 const 0, I think is what we did, I think. I can't remember. Something like this. And then we should be able to load that thing. So we just return i32 const 0 is like the first element, and then the length, we have to just calculate the length, I guess. So this is going to be 11 or 12 bytes. And then we can call, what was like the call function? I've already forgotten. Call log here. So let's just try that, I guess. So that compiles. Okay, and if we go into our index JavaScript, we have our env log function passed in, but now it's going to look a little different. We're going to have to look at the memory in our thing. So maybe we'll stash the exports here. Is it var in this language? I can't remember, but hopefully we'll be right. And then here we could say exports is equal to results instance exports. Then we call hello world. And we're hoping that we get back here, and we should be able to get, like, the string from the memory. So we should have exports which we exported it as memory, I think, as mem. Let's just start there. Yeah, let's just start there and see what happens. Which should be open at localhost 8000. You first time I'm catching stream, I guess you're streaming a bit late. Nope, I stream at the same time every day. So I don't think that's it. I don't think. But glad to have you. Glad to have you. How did the video editor turn out? It worked well enough to do something. Like, I used it and it worked okay. But then as soon as I started using it, I realized that I didn't want to cut down videos anymore. Like, I just was like, I'm not happy with anything that I make. And so I just stopped working on it, like, immediately after. But it got to the point where it was, like, usable. The, like, indicator, there was, like, an indicator on the text view, and you could, like, scroll around on it, and it would, like, auto scroll and stuff. It was an interesting project. Yeah, the project was fun, but I just stopped caring. It happens sometimes. It's not the end of the world. Not the end of the world. We'll live. We have to compile this thing, I guess. Refresh. We still don't see the function. What if I force refresh? Control Shift F. Okay, so now we have a function. Okay, and we have some memory. Okay, and we can look at that memory. And how do we like get something out of it? Get. We'll just look at this, I guess. Over here somewhere. Over here. WebAssembly memory. And how do I like extract some stuff out of it? Memory.buffer. Probably I just look at. Exports mem buffer. Okay. Yep, so how do I guess I console log this thing from arg to arg plus arg2. I don't know if that's like valid JavaScript syntax. It's been a second, but let's just kind of see. So he doesn't like that at all. How do I like JavaScript slice array? I guess I just call slice. And maybe we look at the offset to the end of it. Maybe. Maybe not. Okay, so we got a array buffer here, which is promising. What do they do in their console log function here? They create a new uint8 array and then decode it. Okay, let's try that. Let's just see what that does. Let's see what that does. So this, we look at our exports mem buffer from arg to arg with arg2 length. We decode this thing, and then we log the string. Oopsies, I didn't need to compile anything. It's all JavaScript. Okay, so we got a hello world. Our length is 1 too long. So here, we reduce our length to 11. Refresh. No, still no. Oh, we didn't compile. We always have to compile. There we go. So we got like our little hello world string, which is nice, out of our WebAssembly module. But I'm really unhappy with this. But it could just be that like maybe we're not supposed to code these things by hand. Because yeah, it looks like these guys had like the same questions, but this was 3 years ago, 2020. So like, or 4 years ago, 3.5 years ago. So I'm not 100% convinced. Not 100. Was that really outputting uninitialized memory? It did feel that way, huh? It did feel that way. Okay. So we have like some way to like store a string in WebAssembly and copy it out to JavaScript. So we'll say this is like hello world from wasm. And now let's try to do some sort of like text filtering. So it looks like, based off of this model, if we wanted to make some function that's like filter, or like, yeah, filter text. Wait, is this Lisp? I think it uses S expressions, which is very Lisp-like. I've never really used a Lisp, so I can't really say how similar they actually are, though. So we're going to take in, I guess, some offset in our memory, some length in our memory, and I guess we are going to return an offset and a length. That's what I would want to do, right? So like, say we want to like take a string and copy it to somewhere else, but remove all elements that are of like one letter or something, just to play with it, right? I don't really know how I can't return two values, I don't think. Are you writing raw WebAssembly UBs? I mean, I just want to understand it. So I feel like the only way to understand it is to do, you know? Can we like WebAssembly return multiple values? Is that like allowed in some way, shape, or form? Functions can return an arbitrary number of values. Oh, okay. Oh, it's a proposal though. Does anyone support multi-value wasm? Okay, we can try it. We can try it. So let's just like shove two results in here, because I don't know how else you would return an offset and a length. Do you do it like this? Is this the syntax? Dude, this is written by someone who's old. Anybody who's saying all the things this late in the game is crazy. This is like, this would have died in like what, 2014? Right? This is old as shit. Like, this was 2010, and surely it was old by 2015. That's crazy. Oh, I see. So they just slap multiple i32s in here. Maybe create a tuple struct? Is that allowed? Are there wasm structs? Like, are there... Like, I don't know if that, like, exists. I guess, like, wasm type alias. I'm dating myself by saying that. No, I'm saying they're dating themselves by using it now. That's insane. That's an insane behavior. Yeah, okay. I don't really... I think I saw something about types somewhere. I just want to double check that. That would have been in, like, wherever all of those documents... Like, wherever the list of instructions were. Which I thought was here. I thought this was here. WASM instructions. Thank you. Thank you, Mackie. But we want... So here they have... Oh, they have types that are just these. Result types classify the result of executing instructions or functions, which is a sequence of values written with brackets. So result type is a vector of val types. Okay, so you can specify more than one. Is kind of what they're saying. WebAssembly... Oh, text format's here. Types. Okay. Functions? Function types. Yeah, so vector is just... Where did vector go? Oh, here. They're just a bunch of stuff in a row. Okay, yeah. So we should be able to... Like, that's kind of saying that I should be able to do, like... This? I32, I32? Maybe? This is a stack-based language. Don't you return an arbitrary number of values by placing it at the top of the stack? I think that you probably do. I think you just have to specify that that's what you're doing. That's my guess. So let's see how broken this compilation is. He's saying, hey, I don't like this at all. He's saying unexpected token bracket, expected other bracket. Okay, so is it like this? Result I32, I32? Yeah, oh yeah, here we go. Expected 2 I32s, but got nothing. Okay, so here we should be able to say, we want to like allocate new memory. We want to copy old memory into new memory in chunks. Well, let's do something like exclude all E's, right? Let's do something like that. So we need to do something. We want to do something like loop where we find next E, copy to next E, skip 1 byte, go next. Right? That's like kind of what we want to do here. But before we do all of that, we need to allocate some new memory in our memory bank. So I guess we know that like used memory is like from the offset to offset plus len. So maybe for now, this is stupid, but we should just, well, I guess we could either like make a new memory bank for output, or we could just assume that this memory bank is big enough and stick it after, like just directly after they gave it to us, which is kind of odd, right? Like, how are we supposed to know what's available and what's not? I guess you literally just need a memory allocator, right? I guess that's probably what other languages do. We'll get to like trying to do the same concept in like Zig or C or something, but I guess you would just need to track where all memory has gone to know what's valid to write and not write. But for now, we'll assume that we have some memory bank that's used, like our memory bank is only for us, only for filtering text. And they're giving us something at some value, and we're going to return something at some new value. Yep, you need to create one yourself. But I guess like you can't just like arbitrarily create new memory banks, would be my guess, because we have to export memory banks down here. So it seems like we probably have like a fixed amount that we can work with. But we could do something like filter text output bank or something, and then export that one specifically. But I think I don't want to do that. I think we're just going to use the one we have. And we'll do something like, we have like some output location, which means that we need to write that down somewhere. So local output is an I32. And this is just going to be the position in this guy. And so he's going to start at local get offset. Then we're going to get the length, and we're going to add them together. Yes. And now we can stick that in our output index. Maybe we'll set it for now. I don't really know how we're going to work with this thing yet. Okay. Yeah, okay, that makes sense. Now, maybe we want to use some sort of like offset pointer from the input. Yes, I think that makes sense. So we'll say i32 const 0, and we'll store that in a variable that we will use for input IDX. Okay, that seems reasonable. So which means that we need a local input IDX and i32. Okay. And I guess we're going to make some sort of loop that has to have a name. You can't create memory unless you import them, in which case it seems like you can grow the number of pages. Well, you can like create a memory in the module, but you can't create it on the fly, I think is what you're saying. But you can grow your memory, which makes sense. Okay, so in each iteration of the loop, I guess we will look at the thing at input index, which is offset plus input IDX is our like in. Obviously, this is how you write this language, but I'm just trying to like think through it in my mind. We're going to look at the thing at that value, which I actually don't know how to do. We're going to have to like access the thing. Access the thing. So that's going to be like memory instructions wasm. Something like that. Load a number from memory, which is probably what we want. Yeah. So we load it from here, but this loads it as an I32. But if we have like a byte string, is each of these letters 1 byte in? Like, each of these is 1 byte long, right? Which means that we have to do some like. Oh no, but our length was 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And the offset, we don't really know much about the offset yet. But I guess maybe that means that each location in memory gets pulled out as an I32, even though it's a U8 in memory. That's my guess right now. We'll work under that assumption for now, and then we will see it be totally fucking broken in a minute. Okay. Before we do anything here, let's just make sure that we have our return set right. So let's start by just trying to copy the thing. We'll just copy it with no modifications. So at the end, we are going to want to get the output index into our memory bank, as well as we'll just use the input length. Okay. And then instead of returning this thing for now, actually, let's call log, because we know that works. Let's not get too crazy. And maybe before we do anything, like, oh yeah, actually no, this is fine. We'll copy your input to output. So it should just be so we get the input index. So I32 local get input index. Yep. Then we load the thing at that input. So now we have the value at input on the stack. Then we say we need to store that thing somewhere. So we need to use the store instruction, probably. And the store is the other way. So is there a way to like switch two elements on the stack? Right, because I guess we don't have to. Here we just say local get output index. Then we get the input index and load it. This will replace the second thing on the stack with the value at input index. Then we can local or I32 store. Probably. That sounds reasonable to me. And then we just have to increment both the output index and the input index. So we'll say local get input index again. I32 const 1 and I32 add. Okay. Yeah. Local set input index. And then we do this again. So here we have output index on stack. And here we should be able to local set output index. That sounds kind of right to me. That sounds right to me. I'm down to try it. I'm down to try it. So this guy is called filter text, which we are exporting right now. And so we should be able to wasm to wat, or wat to wasm, sorry. He doesn't like this because I32 at line 35, this add doesn't have what we thought. So here we get the input index. So here we have output index on the stack. We load and store input index. So that's completely gone. We get input index again. We add 1 to it and we store that. So this should be also a no op. So why is this a problem? Why is this a problem? Oh, we have to store it at some offset. So here we are storing at output index. So this store consumed this output index. I see. I see. So I was wrong. I was wrong. Okay, let's try that. So here we should be able to, I guess in our index.js, call filter text, and hopefully we see hello world. That's what we're hoping to see. That is what we're hoping to see. And so we should just be able to go to here, hit refresh. We see empty string. Fuck me. Fuck. Okay. So what did we do wrong? What did we do wrong? Let's go into our index JavaScript and maybe log at the very least what we're getting here. Oops, I don't have to compile it. We just refresh. So he's getting that the offset for output index is 1. And the length is 0. So we just hard fucked up. Oh, because we never go back to the beginning of the loop. We never loop. So we have to do some sort of... We have to branch back to the beginning of the loop on some condition. So what is the condition? The condition is that we have stepped length values or something. Okay. So we want to do like input index. We get the input index. We get the length. Oh, we get the offset, the input offset. We subtract those two things from each other. This is how far we've moved. Now we have how far we've moved on the stack, and then we can get the length. And if we have moved greater than or equal to the length, then we call it a day. So we just do i32 less than signed. That if we are less than the length, then we keep going. That sounds promising. I don't know how correct that is. Fuck! Because I called i32 const, this should be local get offset. Let's try that. That compiles at least. Refresh. Force refresh. He still thinks that it's 1 and 0, which is surprising to me. Surprising to me. So first of all, oh, do we just never set open index? We do. Oh, wait, we're not calling this with the right arguments. We're a dumbass. We're stupid. BR breaks if true, not loop. I'm pretty sure that's not true. Pretty sure. Pretty sure, but we can check. Branching on condition. So given some loop, if I is less than 10, branch to loop. So if I is less than 10, we branch. Yeah, I'm pretty sure that this is... I think it's break and go backwards, depending on if you're in a loop or a block statement, if I remember correctly from last stream. If I remember from last stream. Okay. Okay, so we actually have to call this with something. BR for branch, not break. Yeah, I agree. How readable is wasm generated by the Z compiler converted to what? We haven't really got there yet. But hopefully we find out. So somewhere we must be able to, like, they must have an example of pushing a string into wasm. Let's see. Memory bytes string. So this is decoding, but can we like encode the memory, encode stuff somehow? Log all memory. Oh, so they just set it all from here. I would like to set the data from the JavaScript side. Surely that's not that hard, right? We should be able to, like, is there like a encode string into wasm memory JavaScript? Uh, so they create a memory. I guess if I just write into the uint data array, like that's how this works, right? So we say something like, I want some bytes at this buffer, and I want it to be at offset 0, length 11. And then I want to put the string hello world in there. So can I do like encode string to uint 8 array JavaScript? Here we go. This looks like text encoder. This to get a uint 8 array. Okay, but can I can I put it into? I want to put it into like the WebAssembly buffer. Text encoder WebAssembly memory. How to write a string to memory in WebAssembly? Wait, this sounds right. Ah, so he just says call set on it with encoded string. So we were close. I was very close. We were very close. Okay. 6, 6, 6, 6, 6. Let's just do this. This guy looks like exactly what I was thinking. Okay, so we encode hello world. This comes from exports.mem, which is exactly what we wanted. And then we just set that to be the encoded string, and then we call this with 0 and 11. Let's see what that does. Refresh. He doesn't like that at all. Source array is too long. Source array is too long. So do I just do 0 and 11 here as well? Is that what he's complaining about? I8. Oh, he thinks that this is 0 long. Why? Do I have to write buffer here? Do I have to write buffer there? Oh, yeah, okay, wait. That's not the stupidest thing of all time. It's not great, but we're getting somewhere. We got 3 letters in, so what did we do wrong here? Offset, length. So he knows that this is supposed to be 11 long, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And he's saying, I want to start at 22. Which is not right. That doesn't feel right to me. Oh, because output index is moving. So we want to do like, get the length and then sub. Now we should have the beginning of the string. Let's see what that does. What to wasm. There we go. That looks right. I32 load loads 4 bytes. You will want I32 load 8U. That's what I would have thought too. Now that you're telling me that there's the load 8U, that definitely lines up. But like what I'm seeing, what I think actually happens here is that when I call I32, wherever the fuck we're getting, when we call I32 load, I think it is extracting the 8-bit thing and putting it into an I32. That's what it feels like is happening. Oh, maybe WebAssembly text is inferring the type. Or you read a bunch of zeros after the hello world and JavaScript is ignoring it. But it can't be, right? Because, like, here, right here, I am load I32 from address 0, right? Then I am store I32 from at address 11, right? That's like what this is doing. And then the next iteration of the loop is going 1 and 12, 2 and 13. And so what should be happening is we should be overwriting. Oh, we could be overwriting the previous store. Wait, that would still work. So on a little Indian system, that would result in the first thing doing HELL, copying that. Then the second thing would load ELO, and then copy LO to byte position 1. And then we would load LLO space, and then we're like overwriting over and over and over again. That could be what's happening. Okay, so we could actually prove that by breaking out of this loop early. So we can just say, we can just pretend the length is like 5, and if we're right, then we should get 9 bytes of hello world. I think. Maybe. HELLO. That's only 5 bytes. Oh, but we store it, we call this with the length here. So can we call this with length plus 5 or something? Plus 4? Okay. So that doesn't look, that's not how I was expecting it to be broken. Not how I was expecting it to be broken. Let's double check. Let's double check that this is well, hold on. There's something off here. Why am I saying hell twice here? Are we printing this input string or something by mistake? Output index. We do add 1 to output index every time. What is offset? Is just the input thing. Okay, I don't know. I'm not really convinced in any way, shape, or form. What also, this doesn't really matter. What I'm more interested in is the memory model right now. So maybe we just continue on, plow on, and let's just do one last thing because it's fun to, it is fun to get this right. Let's just say, if the thing is an E, we move on. So we just don't copy. We don't copy if it's an E. So how do we do this? It's here. It's here. We skip this store. And we skip, how much do we skip? We skip the store. We still increment input index. That still has to be done. But we don't want to increment output index. So here we would do something like move this store down here. Move this store down here. Output index is possibly being skipped. Input index is not. Okay, so all of this stuff won't happen. This does happen because this is the exit condition of the loop. So we need to do something like block. Compare. Oh my god, my brain. My brain, it hurts, it hurts, it hurts, it hurts, it hurts. This is so hard. Is there a way to like duplicate a number on the stack? Convert. Like wasm duplicate value. Duplicating the top of the stack, that's what I want. Doesn't have stack juggling primitives because it has locals. To duplicate the top of the operand stack, you need to define a local variable of the right type. Then you can use the following instruction sequence. T local, get local. Jesus Christ. Okay. Guys, I'm calling it. There's no point. There's no point. I'm not going to do it. We're not doing this. It's too hard. We got to the point where we can copy the string. We understand the memory model. We're just not doing this. Fuck this noise. My head hurts too much. My head hurts too much. Let's do it in C. Or Zig? Let's do it in Zig. Zig text filter. We'll get crazy. Okay. What is this? No, I don't care about this. I don't care about this. And, okay. How do we make a Zig WebAssembly module? How do we compile a Zig WebAssembly module? I don't want WASI. I don't want WASI. Zig wasm compile flags. Like, I just want... Give me the simplest fucking answer. Zig build arch wasm32 wasm zig. Then he's linking it manually. Sure, I think there's a way to build it directly. I think I saw that somewhere at some point. This looks familiar, but then I think that I saw somewhere else that in Zig 0.12 you have to use build exe with no entry. That's how I'm remembering it. I did this recently. Yeah, so freestanding. This is Zig 012. Okay. Okay. Oh yeah, so this is an executable. Yeah. So you're doing build executable with wasm32 freestanding. That's it, right? So I should be able to do like something like pub function or pub export function some func. And he's going to return nothing. And I want to do like const-u8 as my input. Let's start. I don't know if we've done any Zig compilation yet at all, actually. So let's start by just calling that log function. Maybe we start by implementing the POW version. POW. So we have two numbers. And we call, is there stood math POW maybe? Let's see how crazy we can get here. Stood math POW I32AB. Let's start here and just work our way up. We will work our way up. Okay, so Zig build exe. I want to know where I found this. I found it somewhere. Zig build exe wasm no entry. Like, I'm pretty sure I saw this, and I just want to make sure. Like, I just don't know where I got it from. Like, your thing is useful. I know that I did this somewhere offline, but it's fine. It's fine. Okay, so how do I specify the target again on the command line? Dash target is what someone is saying in chat. That sounds right. Maybe it was here. Let's just see if this is what I looked at. Doesn't look like what I saw, because I saw something that had like F no entry. But it's okay. It's okay. We'll get there. Target is wasm32 freestanding. Test Zig. And then here we say F no entry. And then I think the thing that made this usable for me when I tried it was like release small. Stripped out a bunch of bullshit. So now we should have somewhere test wasm. I think this is what we just made. Let's just double check. Yes, and then we can do wasm to what test.wasm to look at what it did. Fuck. Nothing. Where is our function? Pub export function POW. Return stood math POW. Why isn't that there? Why is that not there? Is that why you guys are saying I have to type dynamic? Where's my wasm to what? Here we go. Okay, wait, this looks more right. So here we have some function, and we export pow as that function, and it's doing some wacky shit. So can we like kind of like skim this down into like our shitty version of it from yesterday that handles way less? It's just you know, var ret is equal to a. We'll call this base and exponent. So the ret is the base, while var iterations is equal to 0, while iterations is less than x, iterations plus equals 1, and we say ret times equals base. Return right at the bottom. We build this thing. He doesn't like this because iterations has to be a I32 just to match types. And we look at this, and now we see something that is similar to what we did the other day, I think. So we see he jumps back to the beginning if these things are... Oh, he breaks out of this block if we have hit the end of our loop. Otherwise, he subtracts 1 from the parameter. Then he does this, like, the multiplication. Okay, so that seems something somewhat similar. What is the dash dynamic flag versus dash r dynamic? Zig dynamic, r dynamic. Somebody should tell me what this means. Static and dynamic linking. Zig build exe help. Let's see, dynamic. So R dynamic adds all symbols to the dynamic symbol table, and dynamic forces output to be dynamically linked. Okay. Sure. Ooh. He can't specify he can't dynamic link that thing. So by specifying R dynamic, he's forcing everything into the symbol table. So when I did this with no R dynamic, I didn't get my function. When I said dash R dynamic, he goes, oh, I guess I need that function to exist. Which is interesting. Okay. So we should be able to load this module in our index JavaScript. And we should be able to call how to 3. And we should get 8. So we should be able to console log this thing. Except we're not loading from module wasm, we're loading from test wasm. Okay, let's see. Refresh. We're off by 1, like last time. We fucked this up both days in a row. So this should be less than x minus 1. What zig build refresh to the power of 3 is 8. Okay. So that's step 1. We have a zig module that we can like do some mathematical operations on 2 numbers with. Now let's look at the function callbacks. We need to figure out how to get those in. So it's going to be something like log takes in, like let's just start with a I32 parameter. 2 I32 parameters and returns nothing. Let's see what this does. So here we'll call log down here. With what we did yesterday was we called like log with ret and 4 or something. He doesn't like that because there is a signature mismatch here. Is it because I'm like overloading a function name? My log. Okay, that compiles, and if we wasm to wat this thing, ret start from 1, not base. Yeah, that's why. Good point. So he assumes that every function that we get is going to come from the env spot in the dictionary. So in our index.js, we can say we have env and we have my log. He takes in 2 things and he just logs them. And now we should see, do Did we build? I think we built, yeah. If we refresh here, we do see our 8.4 logged, which is good. That means that we have access to a JavaScript function from within Zig, or I guess from within our wasm module. So we've got that figured out. Now let's figure out how to do like text manipulation. So what happens here if I say build like hello world? Let's do the hello world version of this thing that we just did in the low level wasm thing, right? We did this thing and we said we're going to return some string and we can just return hello world. Like, what the fuck is this going to do? Oh, okay, it's not allowed. Okay, but we can return a C pointer to a constituate, and I guess we're actually gonna have to return that thing and its length. So, how are we gonna do multiple return values here? Do you think that if we do like hello, like string ret, or maybe we'll just call it string? Do you think if we make like a struct here that has 2 values in it, what do you think is gonna fucking happen? Like, this is the constituate and its length. Can we do this? Can we do like this? So const val is hello world, and then we take the val pointer and the val len. Like, is this a valid way to return a string if in this language? Who fucking knows? Let's fucking compile it and see what happens. No, he doesn't like that, because we can't export a string structure like this because we're in calling convention C. Okay. So we can't define a structure and return it. We can't return a tuple. How the fuck do we return a string? Can you do like output parameters? Like, can you say like out len is a usize and out, then do like out len is equal to val len. Here we return the C pointer. Can you tag string as a C struct? Maybe you can return struct in C. That's a good point. Maybe there's something there where we have to specifically ask for a specific type of struct layout or something. Oh, maybe the tuple struct is bullshit. Like, because maybe I can't have anonymous struct members in C. Maybe. We'll come back to that in a second. I want to see if out pointers, or if like output arguments works. Okay. What happens if we do this? Does that compile? That compiles. And what does it do? Wasm to what? So if we look at our, this is the function here probably. We return this number 1048576, which is here. So he says, hey, I have this data at that value in memory bank 0 probably. No. Yes. Okay. So this is interesting. So we have memory bank 17 pages wide. For whatever reason. Who knows why. He creates a global of type I32 that he sets to be the offset of the data. Which maybe is not necessary. Maybe not. Stream says you're doing WebAssembly string manipulation, but looks like you're coding Rust. We're coding in Zig right now, but we're generating wasm. We're generating WebAssembly from Zig and then loading that from JavaScript right now. But eventually we're going to turn this into loading it from C, or from Zig through C. That global is a stack pointer. Let's see. If I make 2 values, let's just do this again. Make a second hello world function. You should make the stream title doing all the things. I'd look so old. Okay, so we have... That's interesting. That is not what I expected. Very interesting. So you're arguing that this global is the stack pointer. And so he probably starts at like big number and works his way downwards, right? So that's probably why 17 here lines up with a 16 kilobyte stack. Can I change the stack size? Can I change the stack size in the compilation options? This isn't what I want. Zig build exe help. Can we do like stack? Okay, so we can pass stack and make this like 1024 bytes. So this should change our memory to 1 page long. Our global stack pointer moves to 1024, and our data starts at 124, and it concatenates it all together. Okay, that makes sense. That makes sense. So these numbers are like the same because one of these is exclusive and one of them is inclusive. Makes sense. And can we, like, do we see the global stack pointer move? What we can do is we can maybe in here, let's make a second function so that we can see the stack pointer move. We can prove to ourselves that that global is a stack pointer by incrementing the stack in some way, right? Right? So if we call like function myfunc, and he has, you know, like he takes in 2 numbers, and he calls my log with a and b, and in pow we call, in each iteration we call like my func base like ret and iterations or something, we should see the stack pointer move. So here we have our this one's the pow function. I don't see. Oh, it's probably fucking inlining. Where's like call in here? Yeah, because it's just inlining it into the power function. So can we like actually like log this as no inline? Zig no inline. No inline. Zig build. Okay, so now he's calling 4. That's good. And before he calls 4, does he move the stack pointer? No. You need something stack allocated like a structured way. Not too familiar with Zig's allocation strategies. Oh yeah, maybe it's like it's just not doing enough for it to be a big problem. So we could do something like const something is a bunch of 1020 100 U8s, and for like, can we, I'm trying to like trick Zig into not optimizing things out, which is maybe a little tricky. Like, can we just do this? How stupid is it? It's probably going to be smart enough to get around that. Probably. I can't see. This should be I32s, and then let's do 25 here instead of 100, so that we don't get too crazy. Call 4. 4 is here. Yeah, it's too smart. It's too smart. Okay, but I believe you. Let's just say I believe that this is the stack, because at the very least we saw this number move. And here it does seem like he is smart enough to return the address in his one chunk of memory. So if we call hello world from index.js, we should be able to do something like exports is the exports are, if we say hello world, I'm going to get some offset, and I have to call it with an output parameter. How do I do that? What does that do? We got distracted. Wasm to wad. So if I pass in to my hello world, an I32. Is it just not doing anything with it? Right? Like, let's just go back to only having hello world here. Zig build. So he says, hey, I would like to store the length of this thing in that I32. I32 store. Oh, okay. Sir, so he says, hey, I want to get the thing at this address. I want to put the number 11 there. So that's what these three lines are doing. They're putting 11 to the thing at that address, and these returning the pointer. Which means that the pointer that we're getting in Zigland is a memory offset. So we need to basically create some memory managed by JavaScript in order to do this. Yeah. That's what they want. Is if we were to do it this way, we would do something like create a new memory bank. Oh, can we do that? He doesn't know which memory bank. He's assuming memory bank 0. So we would have to do something like okay. Stood heap wasm allocator. This exists. Right? So presumably this guy is going to handle getting things in and out of our memory bank. So if we were to do something like allocate usize, this is going to return a usize pointer in our memory bank. And we're going to call stood heap wasm allocator alloc usize create. Right? Or else, or catch, I don't know, like, unreachable. What we do now is we say exports alloc usize. This is the length, right? We pass the length into our hello world function, right? And then we have to look at it. So we say exports memory. What is the yeah? He exports his memory like this. We have to somehow extract the usize out of the memory at that location. Uint. So I think it was like new uint 8 array of this memory buffer at offset len length. Oh god, do you think a usize is an I32? It must be, right? It must be. So can we do like uint 8 array cast to int JavaScript? We must be able to pull this thing out. Data view. Yeah. So we say, hey, I want to look at this thing. Data view JavaScript. Do I need this uint data array, or can I just go straight into data view? I can like look at some buffer. Data view. Get uint32 at this byte offset. Oh yeah, okay. So I can just say, what is the second parameter of this constructor? Data view buffer 12 byte 12 for the next 4 bytes. Oh yeah, okay. So we can say I want the buffer at len for 4, and then I can say view get int32. Get uint32 probably. Okay. Yeah. Get uint32. And does the thing need to take? I guess it probably makes more sense to go Maybe say we start at 0 here, and then we pass len and the length here. Like just this. Len u 32, I guess. And then can we like console log len u32? Let's just like see what happens here. Let's just see. You will need to pass the little Indian argument. This bit me too many times. Maybe. Maybe not. Let's make ourselves angry first. We have to feel the pain in order to remember these things. Okay, so alloc usize is not a function, so maybe we have to zig build. Refresh. Okay. He doesn't like buff.buffer because I just copied that from the internet instead of using exports memory buffer. Okay, let's try that. Refresh. And we did get a big ass number here, which again does seem fucking wrong. So let's try little Indian. What is the parameter here? Data view, like little Indian indicates whether it's little false or undefined big Indian. So we need this to be true, I assume. Nice. Okay. That sure is 11. That sure is 11. We're on the right track. We are on the right track. So we should now we have the length as u32, and we have a pointer here. So we should be able to, it was text decoder. What was it? It was like, new text decoder using a uint8 array. From exports memory buffer from pointer to len u32. So this is var uint array. Var decoder is equal to text decoder from the uint8 array. And then it was like dec decode or something. We're gonna have to look it up. Text decoder. Oh my god, why? Oh god. Okay. Do you have an example? Okay. So this was a new text decoder with nothing, and then we decode the uint8 array. Maybe we need to pass buffer here, but whatever, we'll see. Const stir is equal to this, console log stir. Let's see what that does. Where is our tab? I don't know. Localhost 8000. What did I just open? Fuck this. Okay, we got our string. That's really nice. Really good. So we have a way to pull a string from Zigland out into the real world. Now, what if we want to edit a string that we got from the real world? I guess in that scenario, we're going to have to take in two pointers, right? One is the data s is going to be a c pointer to some u8s, and the len is going to be a usize. Yep. And then we're going to return out len like this. Yes, that makes sense so far. And let's just start by allocating a new string. So we'll say we're going to allocate some string. Probably const. Yeah, that's probably fine. What is it? Alloc. And it's going to be u8s. And we're going to need, like, len amount of them. That seems reasonable so far, right? Because if we are taking a string of length 1 and we're trying to maybe take out all of some letter, then we're good here. I guess in that case, we do still need to specify an outline. You don't like the star C pointers, but we need to use star C pointers if we're doing C interop, right? We can't do this. I guess we could do, like, null terminated. But we don't know, they're not null terminated. So I think we do have to do C pointer like this. Because it said I couldn't return normal slices. Oh, just no C? I just do this? Ah, okay, let's try that. Right, multi-element pointer. It would allow that. Yeah, that makes sense. Okay, so at the end here, we return ret. And we say var out var copy is equal to 0. At the very end, we set out len to copied. Okay, all of this is making sense. All of this makes sense. And we just say for 0 to len ret copied is equal to the input thing at len. Okay, so far so good. And then we can get crazy and we can say if s len is equal to e is not equal to e, that's the one we copied. So we should lose the e in hello world. He doesn't like this because I was supposed to write I here, not len. And then here we just say copied plus equals 1. Okay. Okay. So this should filter us some damn text. If we're lucky. If we are lucky. Yeah, okay. So we compile this. He doesn't like that. Because the return type needs to be pointer. Okay. Chilling. This is actually a little sketchy because if we were to free this later, it would break because we wouldn't have like the length associated with it, and the allocator needs that to do the free. But we're not freeing memory. We don't give a shit, so we'll just ignore that problem for now. We will ignore that problem for now. Okay, so we should be able to go back into our JavaScript. We should be able to say, I still want to allocate this usize, but instead of calling it hello world, I'm going to call filter text. We need to find some way to copy our text into this thing. Into like zig memory space. So I guess that means that in test.zig, we actually want like Alex string as well. I don't know if I'm being crazy here. This seems like the way I have to do it. So I'm going to say like, hey, I want like a string of this length. And I just want to do this. Right? Because like how else am I supposed to know from JavaScript side what area of memory is okay to work with? This is the only way to know. It's the only way to know. So I think that seems reasonable. So we're going to say let input s is equal to exports Alex string, right, of some length. So let's say 11 for hello world. We'll call this outlen here. And we need to, like, I guess make a new uint8 array. Input array is a new uint8 array around this thing at input s length 11. And then we have to make a new text encoder and encode that stuff into this place, right? So we say like enc.encode hello world. I think what we did before. Now we should be able to call our function filter text with the input string, the input length, and the output length. Just call it alloc bytes at that point. Yeah, that's not crazy. I agree. There's no reason to call it string instead of bytes. And then call alloc4 for the allocating the usize. Ooh, interesting. Do I like that? Yeah, I guess you're right that there's kind of no reason. Like, because the JavaScript side doesn't really know about the endianness, but we are kind of allowing it to know that we're using it as a usize. Like, semantically, maybe that's different. I don't know. I don't know. Well, I'm going to leave it like this for now, but I think you're right. I think. Is WebAssembly guaranteed with Little Indian? Because if it's not, that's fucked. This is not useful. Endian. Little. Like... Endian. It does say little endian. Okay, that's reasonable. That's reasonable. Does wasm have alignment requirement for integers? That's a good question. Good question. I would assume so. I would assume so because if you are in WebAssembly land, and you do like i32.load from like some memory address like 4, right? I would assume that this is going to compile into a like native register load from memory, which would make me think that the alignment requirements would have to match x86's. Right? That makes a lot of sense to me. But you could also imagine a world where WebAssembly, the WebAssembly execution environment, will check if the alignment is good or not and like do the bit manipulation for you. Both of those would be reasonable to me, and I have no idea which one it is because I have no idea what the fuck I'm doing. But we could, yeah, I guess we'll have to keep an eye out for that, but I'm not going to go into that right now. I don't want to get too distracted because we've already kind of done not anything for an hour and a half. I wanted to get into like way more, but we're getting a little stuck, so let's just keep going. Let's keep going. Shouldn't len be I? O2, I was like, yeah, you're right. Yeah, probably. Where was that? That was down here. Yeah, we're idiots. We're idiots. Thank you. Does raw x86 have alignment requirements on integer loads? I'm almost positive that I have hit CPU traps due to fucking up alignment, which makes me think yes, but I could be misremembering because human memories are fucked. Like, even if I've seen alignment issues, that it could have been when I was on ARM, because I did a lot of ARM development when I was working in, like, camera firmware. But I'm pretty sure x86 integer load alignment. I'm pretty sure it requires it. Is it every data type should be aligned by its own size? These are rule of thumbs, though, but I don't know if it's some x86 instruction sets are byte addressed, some are 32-bit aligned. Okay, yeah, this lines up with what I thought. I was pretty sure that, like, depending on which load instruction you do, like, if you're trying to load into a 32-bit register, it has to be 32-bit aligned, I think. But I'm going, talking to my ass a little bit. Okay, so we encode this string into this memory address. We pass that memory address here, and then we say, hey, can we get this output, please? And then we look at the output from this thing at get uint32 len. Oh, so here we extract the length as a u32. Then we look at this guy, we look at the pointer, we look at the length, and we decode the thing back. Okay, so theoretically, if we did everything right, which we certainly fucking didn't, but if we did, then we might see the word hello world with no E. That would be super fucking cool. But we can't even compile, so like, what the fuck do you want from me? We need to, here, this is var ret is equal to this, and then we return ret pointer. Okay. So here we refresh. We crash because this guy doesn't like len not being defined because we renamed len to outlen. So let's just kind of slap some outs around here. Okay, refresh. He doesn't like this because what? Oh wait, no, he's fine. He's fine. He's fine in that he's not crashing. He's not fine in that this is absolute fucking garbo. Right? So let's start by just doing no filtering. No filtering. Let's just see what we get here. Zig build. Refresh. He still doesn't like that. Absolute trash. Absolute trash. There's lots of ways that we could have fucked this up. Can we... Text encoder. Did we fuck this up? I don't remember. So we take this encoder and he takes an encode string and he returns a uint8 array. But didn't we already find a way to encode into a specific buffer? Encode into. That's what we wanted. Encode into input array hello world. And then this input array is garbage. He doesn't need that. It's the other way around. It's the string into the array. Let's try that. Oh, baby. Okay, hello world is there, but we are missing the fact that it's supposed to filter out the E, which is maybe because we didn't compile. Boom, baby, let's fucking go. Oh, yes, yes, yes. That's sick. That's pretty sick. Okay. Yeah, that's solid. This is complicated as fuck. Right? Like, is it just me, or is this, like, a lot? Right? Like, the idea that we have to use a Zig allocator to write into some memory in Zigland that's, like, wasm allocated, though, and then we, like, get these pointers. The pointers aren't really pointers. They're offsets into these memory offsets, and in order to do, like, out parameters, we need to fucking go in JavaScript and cast these 4-byte uint8 arrays into, like, it just feels wrong. It feels wrong. It would be really nice. It would feel a lot nicer, I think, if we could get rid of this out parameter. Right? This is what, like, is really killing us. Well, this isn't great either. Right? The fact that we have to allocate this string here. But I guess, from Zig's memory model, Zig's memory model, when compiling for wasm, is that he owns the memory. And so, when you work with, like, other C libraries even, like, the idea that, like, allocations are owned by the library, like, that makes sense, right? So that's not too crazy. Maybe it's fine. And maybe this gets easier if we can export structs in some way. So let's do that. Let's look at this a little bit, right? Because, like, say we can allocate a struct and, like, export it in some way into, like, JavaScript land. This becomes, like, so much simpler, because then we can go back to this, like, idea of, like, const string is equal to a structure with a size and a pointer, right? If we could export this nicely, then that would be nice. Rust wasm includes its allocator, right? Okay, so I have worked with Rust and wasm before, and I didn't really look nowhere into this, like, amount of detail, right? Like, you can tell because I'm fucking lost. But what I remember is that when you compile with what's it called? Wasm, Rust, Wasm. Let's see. There's some, like, there's some tool that you use that, like, kind of, it, like, owns the loading of the WebAssembly module. And so it, like, injects all of this shit into your WebAssembly module, whether you ask for it or not. Probably it's in this book. Setup. Wasm pack. Yeah. So this guy, if I remember correctly, he, like, generates some JavaScript files that load wasm bygen. That could be what I'm thinking as well. But I just remember seeing, like, a JavaScript loader that came with it that did all sorts of shit. So I assume that, like, anything that is going on at, like, I assume that it's doing all of the heavy lifting. You know? Okay. So, let's just see, can you, like, wasm c struct? Like, let's just see if that is something that, like, comes up. I fucking hate the internet now, man. This fucking, I have to make an account to read every single fucking article. Fuck you, man. Fuck you. I know, like, I guess who am I to request that all of the information on the internet is free, right? Who am I to request that? But fuck you, man. How do you call a C function that takes returns a struct from a okay, here we go. Okay, this is what, without reading these 4 words, lines up with what I would have guessed. Is that I allocate my I call the allocator to make my array somewhere in memory, and then I can read and write to that array and use it from other places, right? So we could do something like this, right? We could say, hey, we have some function, we have some structure string that we support. In fact, it doesn't even have to be a structure. We'll just say that we have like a slice, right? And instead of returning this slice, we will return a pointer to this slice, which is an important distinction. But it feels minor, but it's important. What we can do is we can make a function that's like get slice len. And we can take in our slice, which is a pointer to a slice, right? And we can return a usize out of that. And then we can just call slice return slice len. Yeah, this sounds like this might work. Then we can call another function that's like get slice data. And this is going to return a pointer to a constituate like this. Then we can do like return slice pointer. Hey brother, what we working on? I have a project in mind, but I haven't really talked about what it is. But at this point, we are experimenting with the idea of how would we embed WebAssembly modules into a program as a scripting language, approximately, right? So like instead of embedding a Lua engine in your video game that controls your characters through plugins, you could instead embed WebAssembly modules and you get like really good sandboxing theoretically, right? Because it has to run on the web. So like the WebAssembly sandboxing should be pretty good, is my guess. And 2, you can like write stuff in any language, and 3, it should be efficient. That's kind of like the thought. So we're like just experimenting with WebAssembly in general to see if that's like a usable idiom. And if it is, then we can work on like a project that uses it. But if not, then no big deal. Okay. So say we have like some slice that we pass in now. Now when we take in, can we do something like, here we take in a pointer to some data. Text. And here, then we export a pointer to some data. Then we can like work with like Zig types, and just when we're populating them from JavaScript, use these Zig functions to get the appropriate things out of them. We can try that. Let's see what happens. So let's new call this stuff. We'll call this alloc u8 array. And this is going to return, like, do we want to do this? So we like do like a double allocation just to dodge some shit? That doesn't seem crazy to me. Oopsies. Oh fuck, what did I just do? So here we allocate the inner thing, and then we return. So this is the slice of this length. Then what? We say const ret is std heap wasm allocator create a pointer to that slice. Okay. Maybe. And then we say ret is equal to slice. and then we return ret. This double allocation seems stupid, but I feel like it helps us in some way. But maybe no. What the fuck are we talking about? What the fuck are we doing? Oh, yeah. So the reason we're doing it this way, the reason for that is your slice is essentially pointer, which is some U8s somewhere, and a len, and we can't lose this length. So in order to not lose this length, when we pass it to JavaScript, we do like a double allocation, which blows. Good eye on the wrong star. I shouldn't have put a star there. You're right. So we turn this thing. Should error really be unreachable? No. But I don't know what else to do right now, so I'm just calling it unreachable because I don't give a shit about correctness right now. Right? It's just like I'm trying to get it to compile. I know that it's not going to error out in our specific case that we're playing with right now, and we would have to harden it a little bit more for like real usage. Okay. So here we should now be able to say, instead of doing this wasm allocator alloc, we can probably get away with like a dupe of the thing at text. Yeah. Then we go to text len. This is text at I. And then we don't have to do this like bullshit here. And we just return ret. Except that this ret is the wrong thing. We need to do this second stage allocation again. So we'll call this, we'll just do this, ret2, fuck it. Ret2 is equal to ret, and we return ret2. Maybe this is fine. I don't know if I like this better or worse, to be honest, than the other way. But first, let's see if this compiles, and then we can talk about if it's better or worse. Okay, expected 2 arguments, found 1. So dupe needs to say that it's array of U8s. Text I needs to be like text.star. Okay, so this compiles. And now in our index JavaScript, we should be able to say, hey, I want to allocate a U8 array. And in order to figure out where it is, I actually have to call exports get slice data from here and call exports get slice len from the same thing. Then here we call filter text with input s. No lengths have to be specified anymore, which seems cool, very cool. And we don't have to deal with like this like outlen bullshit anymore either. Right? We can just say that the length is this is result. And here we say exports get slice data res. And here we say call exports get slice len res. Oh, that actually feels pretty damn good. That feels damn good. Okay. So that's pretty close. The only problem, so this did what we wanted, just for the record. It's almost all working. The only problem is that when we return ret2, we're actually going beyond the edge of the thing because of the fact that we're now using the built-in pointer length. So we actually do have to do like a truncation here, where we would do something like off by 1. No. It's because what we were doing before was we had like return value was allocated at size 11, but we were returning out len as 10. But now we don't have this out len thing, so we're just returning the size of the allocated thing. But if we were to do this, if we were to say that we were to allocate this thing of text len -1, because we know that there's one E in the string that we're dealing with, which is like bullshit, but you know, that's fine for our exact usage. Now it's doing the right thing here and saying hello world without the E. Now the question is, do I think that this is reasonable, right? Because something I was thinking about was that it would be nice if we could write programs in this scheme where you could compile them as a shared object or a WebAssembly module and kind of use those two things interchangeably. This like pointer to pointer shit kind of makes the shared object version of that shit. But maybe that's like a required thing, because this is way nicer on the JavaScript side. Way nicer, right? The idea of like just having objects in memory that you can call like object-oriented functions on, I think that makes a lot of sense. And this would work for any type of struct, which is very nice. So I'll have to think about that a little more. Maybe you could convert the fat pointer into a struct to make it an extra struct so it's C-like and pass around like that. Ooh. I guess the only reason that I didn't want to do that was because I didn't know how to access it from the JavaScript side. But maybe I don't have to? So you're kind of saying like, oh, that's interesting. That's interesting. You have mental stamina. Anybody ever told you that? It's if it makes you feel better, it's only when I'm engaged with something. Like you know, you sit me down in front of like a new video game, and I forget to eat lunch and dinner for that day, and it's like I wake up at 10, start playing the game, and it's 11 p.m. and it's like, oh, it's time to go to sleep, right? Like insanely focused on like one thing. But say it's like doing something that I don't want to do even just a little bit, then it's like impossible. It's so fucking hard. So the mental stamina is only in the case where I happen to like it aligns well, which is like very, very lucky. Very, very lucky that what I get interested in is something that's like extremely profitable. Right? Because otherwise I'd be so fucked. Like so unbelievably fucked. Yeah, some people call that ADHD. Yeah, I never got like an official diagnosis. But my sibling's like a doctor, and I was like, you know, I've been reading some things on the internet, and people say that ADHD is like all of these things, and like I do a lot of those things. And she sent me like a spec sheet, and I was like 9 for 9 on the spec sheet. I'm like, oh, that's crazy. I wish I had known that at some point before in my life. But like also like who fucking cares? Like, does it matter if I can work around like what does like giving it a label do for me? Nothing really, right? Like so it doesn't really matter. Other than like maybe like be able to look up coping mechanisms. But like I don't know if I really need them, so who fucking cares? I don't know. Okay. So somebody was saying, what if we make an extra instruct? Is that something you can do? Like zig export c struct? Is that what you're saying? I can do? Export export function. Can I do like export structs? Const name is extern struct. Oh, extern. Thank you. Const. So we can say like slice is equal to extern struct. And here we could give it like a pointer and a len. And here, instead of doing this, we return a slice. And then we return pointer is equal to slice pointer, and len is equal to slice len. Then here we take in slices like this. And here we take in a slice and return a slice. So that actually does seem like everything we need to do here. Just here we return ret.pointer and ret.len as len and pointer. Oopsies, like this. And theoretically, this all stays the same, actually. All of this. You might have to return star slice.js. Yeah, we'll see. Does it compile? Okay. Well, it doesn't compile because I'm trying to dereference the thing that's not a pointer anymore here and here. Oh, it's text pointer here, I guess, now. And okay, so that compiles, which is a really, really good sign. I wonder, it would be interesting to look at the wasm to watt of this. So when we like okay, wait, hold on. Where's our like results here? So say we return, so we have filter text is func4. Where is the signature of func4? He returns 2 I32s. Oh, sick. Sick. Okay, so our struct of pointer and length is getting converted into an I32 tuple, which is really, really nice. That's really nice. So that means that in JavaScript here, I bet you that if we were to look at this thing, we would see an array of 2 elements. That's my guess. And let's see if this actually works with the way it is right now. It might. Undefined empty string. Fuck. Fuck. So that's even just here, right? If we return early. Zig builds, and then we control shift. So this becomes undefined, which is really strange. So Zig let us compile that. Watt to wasm showed it as returning 2 I32s, but this is not accepting that, which is very strange to me, right? So let's look at like func0 here. Yeah, so here he's returning 2 I32s. So it could be that like, it could be that Firefox isn't allowing multi-return types. I think you could make a U32 array and read 2 values from it. But like the fact that this is returning undefined means that input S has nothing, like no value associated with it. You know? Java, Firefox multi-return wasm. Okay, so blah, blah, blah. How do I know if it... How do I turn it on? Like, it seems like... Well, okay, let's... maybe we can make a example thing by hand. Let's make a new module. And let's say we have a module, and he's got a function in him that results in 2 I32s, right? And we just put 2 I32s on the stack. Let's just start there, and if that works, then there's something else going on. Right? So we should get the numbers 1 and 2 out of this thing. And if we watt to wasm module to watt output module to wasm, we can then load that thing in index JavaScript. We will maybe just kind of comment all of this out for now and do this, and then get our exports here, and then we'll just call exports dot, ooh, I forget what we called it. Oh, we have to export. So we need to export our function. So we'll call this test function, and we'll export test function as test function. There we go. Yeah, so now we should be able to watt to wasm that thing. We should be able to go into our index JavaScript, and we should be able to load module to wasm, and here we should be able to call test function, and we should be able to console log that. Zig, I think we can just refresh the page now, and that should work. Wherever the fuck we were here. Okay, so this does give us an array of 2 values. So it looks like Firefox is correctly supporting multi-value returns. So why the fuck is the Zig thing not doing the same thing? right? Because like what we have here is a function that results in two I32s, which is exactly what we saw in Zigland. Right? Like we saw that our function alloc U8 array, where the fuck that was, func0, right? So that was up here. Func0, he... Oh, wait. Wait. We were confused. Test wasm has a function that takes in a param of two I32s. What the fuck? Let's just make sure that's compiled. Yeah, so he's taking in two I32s. And he's setting them in global namespace. Wait, what the fuck is going on? What the fuck is going on here? Test zig. Alloc U8 array takes in a length. Okay, let's just comment out everything else. Because I just want to make sure that, like, we're not doing anything fucking stupid. Zig build. Wasm twat test wasm. So our function is alloc U8 array func0. Func0. Func0 takes type 1 is a function with the parameters of two I32s. Very strange. Very, very strange. So this is just broken, right? Like, surely the zig side of this is just broken. I don't see any other way around it. Right? Okay, let's get rid of let's see. Extra instruct is this thing. Okay. Send person. Oh, so he's probably... Is he doing like... Oh, this is using WebAssembly. This won't work. Frowny face. Are we screwed? Do we have to pass each field as a parameter? That would work. We can do better. The trick is remembering in a system like Zig, struct is simply memory layout. Okay. Yeah. All we need to do is write the TypeScript object into WebAssembly memory, and Zig will be able to read it natively. Okay. So they're just doing this. Which is essentially what we were doing, right? Like, all of our structs have to be pointers because they have to live in Zig memory. But it seems like it should work. Like, there's something... Okay, let's get rid of, like, even more complexity, and let's just start here. Right? So we'll start with pointer is, like... Can we just, like, 1, 2, 3, 4... 1, 2, 3, 4? Is this allowed in this language? And then let's just make our length, like, 1. And just discard the length, I guess. Fuck. Can we, like... Pointer cast. Pointer from at pointer from int. Here we go. Okay, so like this is like as simple as it can fucking get. Yeah, okay. Okay. So what's happening here is when Zig is using a structure like this, it looks bugged. Right? Am I high for thinking that it looks bugged? Right? Like this param I32 means the input to my function is 2 integers. Right? Then he's saying get the 2 integers. Like, he's saying, get the first parameter, which is 2 integers, and store this value in that memory location, but this isn't a memory location. What does type 0 mean? That's a really good question. That's a really good question. The type 0 parameter seems to be the result. Parameter and result. Explicit inline parameter result declarations. This allows binding symbolic identifiers to the name of local indices of parameters. The synthesized attributes of type use is a pair consisting of both use the type index and the updated identifier content. It's so confusing. So confusing. Parameter and result declarations that allows binding symbolic identifiers to name the local indices of parameters. If inline declarations are given, then their input types must match the reference function type. No, I'm so lost. Maybe try to see if the simplified built wasm built returns correctly. Oh, like turn off overly small? No, it's doing the same shit. Doing the same shit. What is the return here? See if it returns correctly. Oh, I see what you're saying. You want to see if we can call alloc u8 and see if so here we should be calling alloc u8. What do we call it? I forget already. Test zig has a function alloc u8 array, and we ask for 10 things. And let's see what it does. Here. Alloc u8 array is not a function. Why the fuck not? Alloc u8 array. What to wasm? Oh, am I loading the wrong thing? Module 2? Oh yeah, this is a test zig. Okay. Refresh. Console. Hello? Am I high? Oh, test.wasm. Oopsies. I am high. I'm always high. Yeah, undefined. Which is what I would expect. That's what I would expect. Okay, I wanted to look at when we go wasm to what? I don't know. There's something about this where it's like wasm output parameters. Like it feels bugged. Right? Because like what's he doing here? His stack starts like his stack ends empty. Right? Because there's no return. Like it's something fucking stupid. Somebody at some point suggested looking at it in C, and I agree. That does feel like where I want to go, huh? Clang wasm. How do I fucking compile? How to compile C++? There's just some target, right? Some target string. Structs might be returned by writing to an implicit struct, or implicit pointer passes parameter. That's how it feels, but then why is the pointer, why is the parameter two i32s? This is, where are we talking? WebAssembly tool conventions. Function arguments and return values. Types can be passed directly via WebAssembly function parameters, or indirectly via pointer parameter that points to the value in memory. The callee is allowed to modify the contents of the memory, so the caller is responsible for making a copy of any indirectly passed data. But the caller doesn't know. Right? I'm just like how the First of all, the parameters to this is two i32s. Return values are just discussed in the next sentence. VARs are placed in buffer by the caller, and the last parameter of the function is a pointer to that buffer. And the last parameter of that function is a pointer to that buffer. The callee is allowed to modify the contents of the buffer. Did I miss a sentence? Return. Similar types can either be returned directly from WebAssembly functions or returned indirectly via pointer parameter appended. But like, how am I, as a fucking like user of WebAssembly, how the fuck am I supposed to know that I have to pass in a pointer parameter here? Right, like that's insane, right? Like I wrote this function, and so now like I have to know to like. I actually still don't understand how the fuck I'm supposed to like use this length value. Right? Like let's just say I write len equals len here. Compile this. So okay, I see. So they Jesus Christ. So they get length 0. The length at parameter 0 is passed in. Then I get the output parameter here, and I store the length offset by 4. That makes sense. Then we get the pointer and we store dead beef in there. But it's just like, where the fuck does this come from? Where the fuck does it come from, man? How the fuck are you supposed to know when you're interrupting with any assembly? I disagree with that, though. I disagree with that. Because when I write assembly, I know what my inputs and outputs are. And when I write C, I know the calling convention. Oh, okay. But you could argue that when you write C, you need to know the calling convention in order to operate with it. But the other side is usually still C-like. So they just, both sides happen to know the calling convention. And here in JavaScript, it seems like it's not using the same calling convention, which is the part that's bothering me. The part that's bothering me is that like we have some sort of output parameter here clearly. But like it's so unclear where it is. Is it stored in memory and global below? I think that this we decided was our stack pointer. This is memory, sure. I'm really confused about this like type 0 thing. So, because like type 0 is just the type of this function again. What happens if you type arm-rf? Yeah, good idea. Let's read this a little closer. Types can be passed directly via WebAssembly function parameters or indirectly. Okay. This callee is allowed to modify contents? Sure, okay. So long, double, and int28 are passed directly as two I64 values. That makes sense. Any structure union that recursively contains just a single scalar value is not specified to have greater than natural element. This calling convention was defined before multi-value standardized. A new default calling convention that changes its behavior and takes advantage of multi-value may be introduced in the future. Okay. VA args are placed in buffer by the caller, and the last parameter of the function is a pointer to that buffer. The callee is allowed to modify the contents of that buffer, so the caller is responsible for making a copy of any VA args. Okay. I don't like it. I don't like any of this. Because I don't know how I'm supposed to work with this, right? Like if I do like var... Yeah, the binding to JavaScript is very confusing here. But we could maybe make a guess here, right? We could say, what if we make a new uint8 array of size 8? And we pass in that array here. Can we set the contents of this? uint8 array. JavaScript. Can we set the contents of that thing? From an array. I just want like memset. uint8 array memset JavaScript. I just want to write all zeros. I just end up with the same fucking thing. How do I... Oh my god. Chat, open AI. Can I memset a uint8 array to 0 in JavaScript? Please. Phil, thank you. Like that? Yep, alright. So what happens if I do this? And then at the end, let's log the array. Let's just see what happens if we do this. Still all zeros. Interesting. Not what I... Oh, but this isn't in WebAssembly memory. So he's expecting it to be in wasm memory. So I have to... Yeah, I mean, that's just stupid. We're back... This is way more complex than just returning pointers. So I think that was the pattern I liked best so far. Was when we were just double allocating, returning the pointer. That felt simple. Because then you can just... Yeah, if you just do this. That felt way nicer. And I think that's probably just what we'll end up doing. Because this is stupid. I did want to look at what Clang would do, though. So let's say that we were just, like, do some sort of... struct slice has a pointer, which is a uint8, or a car star pointer, and a int size. I don't really give a fuck right now. I don't give a fuck. If we were to say, hey, struct slice is returned by my alloc u8 array that takes in a int len, can we return struct slice? I think you have to do this, and then pointer is equal to dead beef, and dot len is equal to size is equal to len or something. Like this, like this. I don't remember. GCC-O, what func? GCC-C-O test.c. Okay, sure. So we just car-star this. Sure. Just to get rid of the warning. So that compiles. Now let's go back to whoever sent me that clang command. So it's just clang. Fine. We'll fucking install clang. We'll fucking install clang. If you want me to, I will. Clang. So you just passed in target and no stdlib. No entry. Okay, sure. This is fine. That makes sense. This also makes sense. This also makes sense. Here we take in test wasm and we take in test C. Linker wasm LD doesn't exist. Fuck off. My life is so hard sometimes. No. What the fuck? Blah. Okay, clang. Compile wasm. This does seem like what I just fucking typed, right? I guess he typed no standard libraries. Libraries. Also, wasm LD saying no unknown argument rpath is crazy. Have I done something all? WL explorer, WL no entry. Nothing about this feels wrong to me, but this does not feel good. Wasm LD, unknown argument rpath. Like, what the fuck is going on there? Clearly, we're just doing fucking something stupid. Did we get the target right? Did we get the target right? Yeah, it was target what? His wasn't 32. It's a Nix problem. Oh, okay, thank you. Fuck my life all the time. LVM packages. 16 LVM. Thank you, thank you, thank you. Welcome to hell. What the fuck? Do I need LVM packages 16 clang as well? Env grep LVM. So here I should have like something like this. This should go somewhere. ls this and like, oh, that's only lib. Fuck off. Do I have bin in here? Include. No, so do I need to just pull in with 17 bin tools as well? Didn't I pull in 6? Didn't you link 16 for the last thing? You did. So just shouldn't I do like whatever version you like? Sure, yeah. So Nix shell p LVM packages 16 bin tools is what you're saying. And does that have clang in it? Let's hope so. Clang. No. What does bin tools provide me? Like, surely I need to pull in clang here as well, right? Are you just saying that the latest is broken, or that the clang wrapper in general is broken? Maybe this. This looks promising. I see. Let's try clang as well. So we pull in clang, we compile clang, and then instead of using the LLD package, we have this LLVM bin tools or something. Maybe try zig cc. Oh, that's actually a good idea. I like that. Unsupported Laker flag, export all. Oh, okay. We're gonna try one last thing. Nix shell clang. It just needs different packages, but link it to work. So conf wrapper issue. Yeah, it's fucking annoying. Annoying, but okay. If this doesn't work, then I give up. Yeah, okay. We're gonna give up for now. Yeah, I'll look into seeing if we can get C compiling off stream, because this is, I think that we will want to compare with C eventually. But for now, I think we had some fun today, for sure. We definitely had some fun. So we ended up, I think the best strategy that we came up with for interacting with strings in Zig from the outside world was allocate a Zig string, allocate a pointer to that Zig string. We called allocate U8 array or whatever with some length that returned const U8 or returned a pointer to U8s, and then we had like wrapper functions that extracted the length and the data pointers from that, and that worked like okay. I'm not the happiest with that, but I think that like based off of what we're seeing on the internet, it does seem like allocating structures in WebAssembly memory and then referencing those is the cleanest way to do this. And I think that like overall, if we're going to do like object-oriented programming or whatever with other structs, I think that'll work. That'll be fine. So apologies for those of you who just came in with the raid. We're actually ending the stream pretty much right now. And for everybody else, I was going to say, if you like what you saw, we stream most days at around 2 o'clock Pacific time from 2 PST to 4 PST. It's 4:30, so anything between like 2.5 hours ago to now. There is a YouTube link in the Twitch description where we have playlists for all of our previous projects. Right now, we're a little bit between projects, but we'll be jumping in tomorrow. I want to look at WebAssembly modules as an extension system for, like, those like ball machines? Here, let's see if we can find this. Tower of Bobble Science World. So I grew up in Vancouver, and there's this thing outside. The best part of going to Science World is there's this like thing outside, and you would like look at this thing. It's hard to see, but this is like a machine where they had like little pool balls going going through this like big contraption. I would just stare at this for like hours and hours and hours and hours. Well, I shouldn't say hours and hours, but like it felt like hours because I was a kid and like time just like flies when you're staring. You would stare at this for forever. Anyways, I like that idea. I like the idea of like WebAssembly as scripts for some process. And so what I want to work on is a like program where users can submit a WebAssembly environment for like one area of this thing, right? So I want to do like, maybe you have like some image here or like some like slice of the thing, and like maybe you have like a piston that goes up and down here, and then like a ramp or something, and then balls come in from the right and they get pushed up by the piston and then roll down here, right? That type of thing. I want like each in like a bunch of individual environments where each environment is described by some WebAssembly module that can be submitted online. That's kind of what I'm thinking right now. So that's why we're looking at this to see like, is the idea of using WebAssembly for this feasible? And I think it is. We'll see. So we'll be back at that tomorrow. We'll be starting on this tomorrow. That's the plan. What else? We plugged the YouTube. If you're on YouTube, you should swing by on Twitch and say hi if you want to. There's a GitHub in the Twitch description as well, where code for most things go up. This won't be up there, but when we start on this project tomorrow, that will go up. What else? Like, subscribe, Twitch Prime, and I guess we say goodbye to YouTube and figure out who to raid on Twitch. Bye, YouTube.